Myself, I am Tony CJ, working as an assistant professor in the Department of Physics, Jyoti Engineering College, Cheruthuradi. Now, we will see the construction of optic fiber. So, this is the general figure for the fiber optics. Here, we will see mainly three components. One is core, and second one is cladding, and third one is protective plastic coating. We will see in detail. First one is inner cylinder, that is known as core. So this is the inner cylinder. The inner cylinder is called core. We will see in detail. The innermost cylinder is called core. So this is the core. It is made up of glass or transparent plastics. In fiber optics, mainly we are making use of that glass or transparent plastic. The refractive index of the core is higher than that of the cladding. So this is the core. We can make either by glass or transparent plastic. Here the refractive index of the cladding is higher than refractive index of the core is higher than cladding. Okay, now the refractive index of the glass enhanced by, so as I already said, the core having the higher refractive index comparing to the cladding. Okay, so we are using the same material for cladding and the core. We are using either by glass or transparent plastic. So normally the core and cladding will have the same refractive index, but the inner cylinder core should have the higher refractive index. So this is the denser medium and cladding is the rarer medium. So in order to increase the refractive index, we are doping the core with boron germania or phosphorus pentoxide. Okay, now the refractive index of the core is increased. That means the core is denser medium and the light travels through the core. So it is also known as waveguide. Okay, so this is the main construction for the core. Mainly the core is making from the glass or transparent plastic, and which will be having the higher refractive index than cladding. So in order to increase the refractive index of the core, we are using boron, germania or phosphorus pentoxide. We are doping with these materials. So the core having the higher refractive index. Now we will see the cladding. So this is the cladding which covers the core. The cylindrical shell surrounded by the core is known as a cladding. So this is a cylindrical shape core, and cladding is also which covers the core, which is also in cylindrical shape. This is made up of glass or transparent plastics. Like a core, this is also made from the glass or transparent plastic. The refractive index of the cladding is smaller than that of the core. So as I already said, the cladding will have the refractive index less than that of the core. So we should have to reduce the refractive index of the cladding. So in order to reduce the refractive index of the cladding, what we are doing? Okay, the refractive index of the glass can be reduced by doping with the barium oxide. So we are adding some barium oxide with the cladding. Thus the cladding will have the less refractive index comparing to the core. Thus cladding is rare medium. So core has the higher refractive index, that means a denser medium, and cladding having the less refractive index comparing to core. So this is known as a rarer medium. So core is denser medium and cladding is rarer medium. Okay, when the light incident on the interface, so when the light is incident on the core cladding interface at an angle greater than the critical angle. So we know the condition for the total internal reflection is that should be the angle of incidence that should be greater than critical angle. So when the light is incident on the core cladding interface at an angle critical angle, then it will undergo the total internal reflection. So main function of the cladding to help the light travel through the core by multiple reflections. It keeps the light signal within the core, not escaping from it. So light signal is passed through the core, so no light signal will be escaping from it. So the core is surrounded by the cladding. which is having less refractive index. So first main thing is the refractive index of the core that can be increased by germanium boron, doping with a germanium boron or phosphorus pentoxide, and the cladding having the refractive index is less than that of the core, and that refractive index can be reduced by doping with a barium oxide. Okay, so entire light that will be passed through the core. Okay, so here the basic principle is total internal reflection. So the incident ray that is incident on the core cladding interface, that will be having more than critical angle. That angle should be more than critical angle, so the light ray will be reflected back. So we will get the zigzag motion in the core. So light is completely passed through the core. Okay, next portion, the third portion, this is the protective plastic coating. This is known as sheath. Okay, this is a cylindrical protective jackets. This is also in cylindrical shape. So it is a protective layer, we can say, around the cladding. Okay, so around the cladding we are using a protective plastic coating, which is known as a sheath. It is made up of opaque or colored polymer. We are using colored polymer. Okay, and so it covers the cladding and core. So it is a protective layer to the core and cladding. It gives the mechanical strength. So the strength of the fiber that can be increased by using sheath, and it protects from the moisture, scratches, stress, pulling and contaminations. So if any external moisture or scratches is happening, the sheath is protecting the core and cladding. So it just the function is just protect the core and cladding, and light waves will be passed through the core. Okay, that's it. So these are the main parts of the optical fiber. First one is core, and which is having the higher refractive index, and cladding, which will be having the lesser refractive index than core, and third one is sheath, that is the protective plastic coating which covers the core and cladding. That means its function is to protect the core and cladding from external moisture or scratches or something. Okay, so these are the main components of the optical fiber. Okay, now we will go to the basic concept. First concept is critical angle. Okay, so as I already said, the core and cladding will have different refractive index. Let's say mu1 is the refractive index of the denser medium. Here core is the denser medium and cladding is the rarer medium. So mu1 is the refractive index of the core and mu2 is the refractive index of the cladding. Okay, now let's say we can say when the light is incident on the core cladding interface, that means core cladding interface means core is a denser medium and cladding is the rarer medium. So light rays is incident on the core cladding interfaces. So what will happen if the incident ray, so incident ray is on core, if the incident ray is greater than the critical angle, okay, that means total internal reflection is happening. Now let's say I is the angle of incidence and R is the angle of refraction. Okay, you know the Snell's law, sin A by sin R is equal to mu2 by mu1, where I is the angle of incidence and R is the angle of refraction. Okay, and mu2 is the refractive index of the cladding and mu1 is the refractive index of the core. Okay, now as I already said, this is the critical angle. When angle of refraction is 90 degree, corresponding angle of incidence is called a critical angle. That means when I equal to theta c, that means angle of incidence is critical angle, this refracted ray that will be passed through the surface of separation between two medias, that means R is equal to 90 degree. So when I is equal to theta c, R equal to 90 degree. So we will just put these values in Snell's law. That means now this is I, replacing I by theta c and replacing R by 90 degree. So what will happen? Sin theta c divided by sin 90, which is equal to mu2 by mu1. Okay, sin 90 we know that is 1. Okay, so sin theta c is equal to mu2 by mu1. Okay, or theta c is equal to sine inverse of mu2 by mu1. If the values of refractive index of the core and cladding we know, then we can easily find out the critical angle. Thus, the sine of the critical angle is the ratio of refractive index of the cladding and core. Okay, generally, I already told the refractive index of the core that will be higher than that of the refractive index of the cladding. That means mu2 is greater than mu1 is greater than mu2. Any ray which is incident at an angle greater than critical angle. Okay, this is a condition for the total incident reflection. If the ray is incident on the core cladding interface and if the incident ray is greater than the critical angle, then what will happen? The light ray will be reflected into the same medium. That means core cladding interface is the light ray is incident on it. If the light ray is passing from core, then if the incident angle is greater than the critical angle, the light ray will be reflected into the core only. It will not refracted into the cladding. Okay, so in basic concept for the fiber optics is total incident reflection. Okay, and for finding the critical angle we will use sine theta is equal to mu2 by mu1. So basic concept for the fiber optics is critical angle and total incident reflection. These are the some basic concepts. Okay, thank you all.